All right, on 8.2, we are problem solving with proportions. Now, in 8.1, we kind of already did some of this, right? We already used proportions to solve problems, correct? Everybody got their books out? Notes? Okay, we're on page 465. Now, also on, it was actually last Thursday, if I gave you a proportion as A over B equals C over D, we also found it true that I could flip these, right? So I could have B over A equals C over D. Oops, D over C. Okay, we found that to be true, correct? Yeah. And we also found that A over C, or was that the only one we did on Friday? That might have been the only one we did on Friday. Today, we're going to find that A over C is equal to B over D. Okay, so not only can I flip them, but I can also go horizontal, right? So I can go A over C, B over D. Notice, they're all supposed to be the same. So that means when I cross multiply, I should still be multiplying the same things, correct? Does everybody agree with that? So when I do that, I take B times C and A times D. Do I do that here? B times C, A times D. Do I do it down here? B times C, A times D. I'm still doing the same thing, correct? So are all three of these equal? Yes. Now the other one, which is a little bit different than the rest, is this. I can also do A plus B over B equals C plus D over D. What did I do to get that? What did I do to the top? What did I add here? I added more than just a plus sign. What else did I add? The B. Where'd the B come from? No, there's no B over here. The bottom. Right? I did the numerator plus the denominator all over the same denominator, right? A plus B over B. What did I add to this side? The D, which was the denominator, and I left it over the denominator, right? Okay, so you take your top plus your bottom over your bottom, and your top plus your bottom over your bottom. Numerator plus denominator over the same denominator. Okay, that's just an extra little one. Now, you are going to have to make sure you know that, because come your homework time, and for sure your test time, I know for a fact it's on your test, they're going to list, or they're going to ask you, are the two proportions equal to each other? And you're going to have to make that decision. Okay, or on your test, when it comes test time, they're going to ask you, which of the following is not equal to this? And then they're going to give you a whole bunch, and you're going to have to tell me which one is not the same. Okay, so they're going to give you for sure these three. Okay, you're going to have to understand that these three things are all the same as this. So be aware of that. That will be on your test. And let's take a look at example 1. They have P over 6 equals R over 10. They want to know, is it true that P over R has to equal 3 over 5? Yeah. Why, Taylor? What did they do there? Right. Yeah, they switched to horizontally, right? So they did P over R and 6 over 10, which happened to reduce to 3 over 5. Okay, so you're still multiplying the same things. Here, when I cross multiply, I'd take 6 times R, right? Do I take 6 times R here? Yeah, if I didn't reduce, I would, right? Okay, and here I take P times 10, and here I would take P times 10 before reducing, correct? Okay, so are those exactly the same thing? Yes. Now the next one, they tell you that A over 3 equals C over 4. They want to know, is it true that A plus 3 over 3 is equal to C plus 3 over 4? Carson, why are you saying no? The right side is not that, because this should be, to be the same, should be C plus 4 over 4. Okay? When you're doing it like this, each side is its own. Okay, you're adding the same thing here. Over here, did you add the same thing? No, those are different. A 3 and a 4, those are definitely different. So, are these equal? No. Those are not equal to each other. Okay, you're not going to have a lot of problems like that, but you do need to be aware of that scenario. Flipping over, we're on page 466. Okay, this is where our proportions really come in. Okay, this is where we're really going to start using them. So I have a triangle. And it's split here. Actually, I have two triangles. I have triangle ABC, and I have triangle ADE. Everybody see the two triangles? Okay. And I'm actually going to switch this up a little bit. They tell me that this entire side is 24 units. Okay. And then they tell me that this is 30, and this here is 10. And then the last thing they tell me is that AB over BD is equal to AC over CE. We have to find what BD equals. One second here, Travis. Now, before I let Travis try to set this up, I suggest, thank you. I don't suggest anything, I suggest it. I suggest that you set it up with these exact segments. Okay. Now, I will tell you, you don't have to. There's other ways to set it up. Okay, but I suggest that you set it up exactly like they tell you to, because if you do, there's no way you're going to mess this up. Okay, if you don't follow how they do it, there's a possibility that maybe you compare two things that aren't comparable. You guys get what I'm saying? Okay, it's very common for people to tell me that they can put AD over AC. That's not okay. They have absolutely nothing in common. But I promise you, some people are going to do that. Okay, so you have to be very careful when you're doing this. I suggest that you do that, AB over BD, AC over CE. Okay, that's my recommendation for you. I'm not going to tell you you have to do it, but I highly recommend it. So if that's the case, let's just go ahead and do it that way. I want to know what BD is, so what am I going to put in for BD? X. Okay, so there's an X. Okay, so let's go ahead and fill in what we know. Do I know AB? No. Do I know BD? I know it's X, right? I now know it's X. Do I know AC? What's AC? Because the whole thing's 30, and that's 10, so that must be 20, right? Over 10. Now we got to figure out this, because this has to be something, otherwise I can't solve this. Okay, notice over here, you took the whole thing minus this equals that. Travis, you have an idea what AB is going to equal? I see where you're going, but it's not always going to be that easy. I want to make sure I know how to set this up. Royal? AD, which is 24, minus DB, which is X. You guys see how I did that? Same thing I did over here, right? Over here I took 30 minus 10, and that gave me that. Over here I take 24 minus X, and that's what I have left over. That's a... All I did is I used segment addition. I knew that DB plus AB equals 24. Segment addition, right? That plus that equals that. Or I guess I can put in AD. Okay, well I know what DB is. It's X. I know what AD is. It's 24. So how do I solve for AB? I subtract X, right? So now I know that AB equals 24 minus X. If that's how you want to set it up, that's fine. You just need to know, if you have this whole thing, and you also have this, if I take the whole thing minus that, that's what I have to end up with. That's all I did. Okay? So when I get here, is there ways to reduce this? Can I reduce this before I start multiplying? 20 over 10 reduces to what? 2 over 1. Now, I want you to be very careful. Last class we discussed this. If I have this, let's make it not reducible there. 6 over x equals 8 over 15. Can I reduce this way? No. Because of this equal sign. You cannot cross-reduce a proportion. Okay? You can reduce vertically if possible, but you cannot cross-reduce. Because here I'm multiplying these two, aren't I, when I solve? 15 times 6. If I reduce that, would I get the same answer? No, and you have to. Okay? You cannot cross-reduce this. Now, could I cross-reduce this? 6 over x times 8 over 15. Yes, because I'm multiplying two fractions. When you multiply two fractions, you go straight across, right? You guys agree with that? So the 6 is staying on top and the 15 is staying on the bottom. With a proportion, you're bringing everything to the top. Okay, that's your big difference. Yes, you can cross-reduce. No, you cannot cross-reduce. Okay, if you have a proportion with an equal sign, you cannot cross-reduce. You can only reduce vertically. Okay, just keep that in mind while you're doing your homework. I had a few people getting stumped on that last class period. Okay, so here I can't cross reduce, okay, but I did reduce vertically. So now when I start solving this, Seth, what do? I cross multiply. So 1 times that is 24 minus x, and x times 2 is 2x. And then I get my x's all on the same side. So I get 24 equals 3x. I added my x over. And then I do what? Divide by 3. So x equals 8. Okay, and then just be careful. Does it want a side length? Does it have labels? What is it asking for? Okay, so just be careful with that once you get going. Questions on that problem? That's what a lot of your problems are going to look like today. Now, do you have to set it up exactly like they tell you? No. Not all the time. Okay, but if you do, there's no way you're going to set up or get something wrong. Okay, and it happened last class period. We did 24 over x, or excuse me, 24 minus x over x, but then they wanted to do 30 over 10. Okay, just because you happen to look over there and see the 30 and think that's what you need to use. Okay, it's not the case, right? Okay, so I suggest making sure that you use the exact same segments that they give you. The next thing we need to talk about, which is going to be a completely new term for you, is what's called the geometric mean. The geometric mean is always going to be set up as a over x times x over b. Excuse me, equals x over b, not times. Equals. It's always going to be a proportion set up like that. Now, could I flip these? Yeah, because of our rules of proportions that we know, right? That could be x over a and b over x, right? You get the same answers. Okay. Now, when I cross multiply this, what am I going to get here? No, I won't get 2x. I'm going to get x squared. I'm not adding. I'm not saying x plus x. I'm saying x times x. When you multiply variables, you do what with their exponents? You add them. So x to the first times x to the first is x to the second, because 1 plus 1 is 2. Okay, now, let's go ahead and do an example here. It says find the geometric mean of 6 and 128. Do those two numbers go in for a and b or x and x? A and b. Okay, so I have 6 over x equals x over 128. And if you don't have a calculator, you're going to need to go get one right now, because you're going to need one today. Okay, and then let's go ahead and cross multiply. x times x is x squared equals, what is it? 768. Okay. Have I figured out what x equals? No, what do I need to do? Square root. Okay, so I square root, and they cancel. I square root here, so I have x equals the square root of 768. Am I done? No. What do I have to do to that square root? I need to reduce it down. Okay, so this is coming back to stuff that we did first semester. What are all these? Why do I have these listed here? Those are all perfect squares. Okay, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Those are all perfect squares. I wrote those because when I reduce this radical, what do I want to take out of it? A perfect square. So what perfect square goes into 768?
4.
Okay, I'm going to start at 4 because I want to have to really break this down and do some multiplying. Okay, so a 4 definitely does. So I have the square root of 4 times the square root of what? 129. Is that? Okay. Because if I multiplied these two radicals, 4 times 192 is 768, right? Okay. What is the square root of 4? 2. Do I have a radical in this anymore? No, because I square rooted 4, so I get 2. Okay, now I need to go back to 192. What comes out of 192 that's a perfect square? 4 again. Okay. So I have the square root of 4 times the square root of 48. Okay. Square root of 4 is 2. Can I break down the square root of 48? With what? Another 4. Okay, so I have another square root of 4 times what? Square root of 12, right? You guys agree with that? Square root of 12. Square root of 4 is 2. Am I done with that? Yep, with that one I am. But am I done with the 12? What comes out of the 12? Another square root of 4 times the square root of 3. Square root of 4 is 2. I'm done with that. Am I done with the square root of 3? Yes. Now, are there bigger numbers you could have taken out? Yeah, and it would have gave you less work, right? Okay, but can you always start with 4 if you want to? Yeah, if you don't want to sit there and punch a bunch of things into your calculator and try to figure out what it's divisible by, if it's divisible by 4, just start with that and go. Okay, maybe it'll work out easier where you happen to see some bigger number just by glancing at it. So when I do this, I get 2, 4, 6, 8, right? No. What do I do with these numbers? I multiply them. Don't add them like I just did. You multiply. So 2 times 2 is 4. Times 2 is? Times 2 is? Square roots of 3. Good. Okay, make sure you multiply those. Yeah, Royal.
Did you do the square root of 2?
Say that again?
2 to the power of 4?
Yeah, which is 16 though, right? Yep. But yeah, you could do 2 to the 4th in this case because you have 4 2's and you're multiplying them all together. Okay, they will specifically ask you, they will say find the geometric mean of blank and blank. Okay, this is how we're going to have to do it. Okay, remember 6 over x, x over 128. Your x's are always going to be there, right? Alright, now the main reason they want you to know that and to be able to solve problems like that is because they're going to, at times, give you something like this. Okay, maybe it's 2 different sheets of paper, maybe it's 2 different pictures, whatever it be. And they tell you that this side is 35 inches. This side we don't know. This side is 175 inches. This side we don't know, but I do know that those two sides are the same length. What do you think, Jacob? Okay, so you're doing 35 over x. Okay, so you have 35 over x equals x over 175. Now, all Jacob did there was set up proportions like we did on the last assignment, right? It just happened to come out as geometric mean. Now, are there other ways to set up this exact same problem? Yes. Would anybody have set it up differently? Travis? No? Personally, I would have done x over 35 and 175 over x. Is that okay? Sure. And there's probably about a total of 8 different ways you could do it. Now, would it have been okay to do x over x and 35 over 175? No. Do x and x have anything in common? They're not on the same shape, are they? And they're not corresponding sides. Okay, so that wouldn't work. Make sure if you're doing that, they need to have something in common. 35 and x, what do they have in common? Corresponding sides, right? They're both the base. Okay, and then I have x over 175, and they're both the sides. Okay, so just make sure you have something in common when you're setting this up. Now, looking at this, I can cross-reduce my 35 and 175, right? No, we just talked about that. Can't do that if it's a proportion, right? Okay, so can I reduce this at all? No, so am I going to get a pretty big number? Yeah, x times x is equals. Okay, and then I do what? Square root. Okay, so I get x equals the square root of 6,125. Now, Royal already said this. Give you guys a second to get that down. Royal already said this. He looked at this and noticed that, didn't you, Royal? What does that mean? That means it's divisible by 25, right? Okay, if your last two numbers make a 25, that means it's divisible by 25. Well, that's good, because over here on the board, what do you know about 25? It's a perfect square. Are we looking for perfect squares to come out? And that's a pretty big one already, right? Okay, so I want to take out, a square root of 25 times a square root of what? What? 245? But the square root of 25 is? 5. Am I done with that? Yep. What can I take out of 245? 49? Okay, so Travis found a really big one. Okay, but there probably wasn't any smaller ones, was there? Okay, so 49 times what? 5. Both under radicals still, right? Square root of 49 is? Does that still have a radical? No, because I square rooted, so I'm done with that. Can I do anything with the square root of 5? No, so Amanda, what does x equal here? Good, 35 square roots of 5. Notice she multiplied everything, correct? Everybody agree with her answer? Okay. Now, a couple last things we need to talk about before we get going here. When I don't know what a side length is, but I want to solve for it, what do I put in? X or some variable, right? If you don't know what it is, but you want to find it, you plug in a variable for it, correct? Okay, and then the only other thing I want to talk about, when can you have decimals in your answers? If it says to. What about if it starts with a decimal? Yeah. Okay, so if it has like 7.6 over x equals 9.2 over 7, can I have a decimal answer? Yes, but if it has 7 over x equals 9 over 7, can I have a decimal answer? No, in this case, I'm going to want an answer like this. Okay, as a fraction. If that's reducible, do I reduce that? Yes. Okay, so just be aware of that. Decimals are okay if you start with the decimal, but if you don't start with the decimal, I don't want a decimal answer. I want an improper fraction, please. Any questions on any of that stuff, guys? It's not too bad, I don't think. Okay, just be careful. Make sure you're lining things up that go with each other. Let me know if you have questions. You have a decent amount of work time here. Okay, here's your assignment for tomorrow.